Today on How It's Made, the top 5 Christmas gifts. The first nutcrackers were plain, purely functional devices. But over time, German artisans became known for their majestic nutcracker kings and soldiers, just like the one in Tchaikovsky's famous ballet. This German company has been crafting nutcrackers since 1928. They make them out of lindenwood because it's lightweight and easy to carve. To make the nutcracker torsos, workers cut a long piece of octagonal-shaped linden into torso-sized chunks. A conveyor feeds the pieces into a multi-station lathe. The first station rounds out the octagon, then forms the basic torso shape. The second station finalizes the shape. The next 4 stations sand the wood so that the wood stain they'll apply later on will penetrate evenly. Next, the torsos go into a vertical router, 3 at a time. It cuts a notch in each torso for the lever that opens and closes the nutcracker's mouth. Next, the torso goes to a drilling machine. The machine simultaneously drills all the holes required to attach the body parts. They stain each torso a dark color. Once the stain dries, they spray on 2 coats of semi-gloss lacquer. Meanwhile, an automatic lathe shapes the nutcracker's head. Workers attach a nose, then cut holes for the eyes. They spray on a touch of red paint to simulate a sun-kissed nose and rosy cheeks. With a steady hand, they paint the whites of the eyes. And the eyebrows. Once the paint dries, they apply glue to the center of each eye, then attach an iris and pupil made of enamel tin. Now they align the head with the torso and screw the parts together. After decorating the coat with buttons and a buckle, they glue a strip of rabbit fur hair to the head. They also glue on a rabbit fur beard to camouflage the notch for the lever. Then they mount the torso onto the legs, which wear painted-on boots and stand on a wooden base. Then this nutcracker percussionist gets his drum along with arms and drumsticks. They top him off with a hat made of spray-painted wood. Most of the nutcracker's parts join together with wooden dowels. A large dowel running across the notch in the torso is the axle on which the lever rotates. Whether you're a seasoned pro or a do-it-yourselfer, having the right tools makes the job easier. Sawhorses support the piece of wood you're cutting, and a toolbox keeps your implements organized and portable. Sawhorses are always sold in pairs because you need 2 under a piece of wood to stabilize it for cutting. This sawhorse is made out of exceptionally strong polypropylene plastic. A vacuum system sucks the pellets into an injection molding machine. The machine forms the pellets into 2 sets of legs and 2 hinged panels, which form a tray to hold the sawhorse legs open. A robot removes the parts and drops them at the first assembly station. Here, a worker joins a hinged panel to each sawhorse leg section and applies non-slip foot pads. These pads keep the sawhorse stable and protect the floor from scratches. She uses a press to snap the hinged panels and foot pads to the leg sections. At the next station, a worker inserts ribbed rubber pads into molded holes on top of each sawhorse half. These anti-slip pads help hold wood steady on the sawhorse. Next, he lays both sawhorse halves on the work table. Then, with a tool called a stamping arm, he snaps the two panels together. This forms a strong hinge which opens and collapses the sawhorse. These sawhorses are now finished and ready for packaging. This two-piece polypropylene toolbox consists of a large storage tub on the bottom and a spacious toolbox on top. Toolboxes are made of standard rather than high-strength polypropylene because it doesn't have to withstand pressure bearing down on it like a sawhorse does. The storage tub, the toolbox bottom, and the toolbox lid are each molded separately using an injection molding machine. In the assembly area, workers apply an adhesive label on the front of the toolbox. Then they install the latches for locking the lid. The latches slide into molded slots. After inserting a removable tray, workers install the lid with a few strikes of a non-marring urethane hammer. Both lid and latches snap in easily because the polypropylene is still hot and flexible. Once the toolbox and tub portions are assembled, workers hang a parts tray on the rim of the tub. Then sit the toolbox on the tray and lock it in place with two large side hinges. And that completes construction of this mobile workshop. The silver used in jewelry today is usually sterling silver. Pure silver is soft and bends easily, so it's combined with other metals to give it hardness and strength. Sterling silver's beauty and affordability makes it a popular gift to give and receive. Sterling is composed of 92.5% silver and 7.5% alloy. The alloy is usually copper or copper combined with other metals. This manufacturer pours the standard ratio of alloy and pure silver into a stainless steel mold. The silver rapidly cools and hardens into a flat bar. Workers send the bar between two rollers, which apply over 3,300 pounds of pressure. Workers feed the bar through the press repeatedly, each time turning a wheel to narrow the gap between the rollers to progressively thin out the silver bar. Rolling the silver bar makes it brittle, so they reheat it to restore its flexibility and malleability. The bar now goes through another rolling press, reducing the thickness even more. In doing so, it lengthens the silver bar dramatically, from 10 inches to 4 yards. The strip now passes through a series of forming rollers, which progressively curls the edges up and inward until the strip becomes a hollow tube. Then the machine solders the edges, sealing the tube. The tube is still too thick for making earrings and rings, so it goes to another thinning operation. This machine grabs one end of the tube and pulls it through a series of circular dies, which have progressively narrower diameters. Once the tube is the required diameter, a winding machine curves it. To make hoop earrings, an artisan steadies a piece of curved tube in locking tweezers. He solders on an earring hook, then a latch into which the hook snaps. Some pieces of jewelry incorporate cubic zirconia stones. In this design, a computer has already cut 2 pattern pieces out of an ultra-thin silver sheet and rounded the sheets into half spheres. The artisan solders the 2 halves together, encasing the cubic zirconia stones inside. The rest of the earring components are made from silver tubing and silver wire. Here, an artisan is making a pendant. He locks cubic zirconia stones in between the front and back frame pieces. Then he positions the centerpiece within the frame, soldering it in 4 spots. He solders a ring to the top of the pendant and the loop for the chain called the bail. Next, a rotating barrel of abrasive powder rounds the edges and smooths rough spots. A buffing with a cloth wheel then polishes the silver to a mirror finish. The same computerized laser machine that cut the sphere earrings can also etch an elaborate design on the surface of a piece. It can reproduce virtually any image that can be created with software. The laser draws by pulverizing a micro layer of silver. As the laser works, a built-in suction device vacuums the silver powder away. Besides adding strength and durability, the alloy makes sterling silver shinier. The copper in particular has anti-corrosive properties which resist tarnishing. Jade is a precious stone traditionally used in jewelry and sculpture. Long coveted for its beauty, jade is now in demand on the putting green. As tough as steel with a feel that is distinctly different, a putter made of jade is definitely up to par. The Jade putter is among a number of new clubs on the green, along with crystal quartz and petrified wood. To make a jade putter, they head for the hills, specifically a nephrite jade outcrop in Wyoming. This stone has taken 2.5 billion years to form and develop a very hard and fibrous crystalline structure. The carver selects slabs that are thick enough to shape into 4 or 5 putter heads. This one has weathered to a rusty color, but should clean up nicely. The color of Wyoming jade ranges from white to green to black. He strikes the slab with a sledgehammer a few times to break it down to a more manageable size. He slices through one of the pieces with a rock saw while flushing it with coolant to save the diamond blade. He makes 9 or 10 cuts to rough out the triangular mallet shape of the putter head. He slices off the ends to complete the basic shape. Next, he anchors the jade in a wooden jig and cuts on an angle to profile the sides of the putter head. He slices off a back section to give the putter clearance from the ground when swung. This putter has really taken shape. He removes material from the corners to center the mass behind the golf ball for more striking energy. He sands the edges to round and soften them. He's careful not to remove too much in one place because that would affect the symmetry. He then polishes the entire piece of jade against diamond abrasive belts. It's an intensive process that takes about 2 hours. He aims a drill and cores into the putter head on a 20-degree angle to make a hole for inserting the putter shaft. A perpetual flow of water keeps the diamond core bit cool, and also flushes out the little bits of filings. He taps the drilled core so it falls out of the putter head. A laser emblazons the product name onto the jade, swiftly etching it into the surface. The putters can be customized with a name and logo. He swabs gold-colored paint into the laser etching to make the letters really stand out. The swabbing leaves a lot of residual paint around the letters, so he rubs it off. He mixes epoxy ingredients now to attach the shaft to the jade putter head. He deposits epoxy in the shaft's hole. He inserts the steel shaft into the 20-degree angle hole. The angle of the hole positions the putter shaft to match the golfer's upright stance. After cleaning and inspection, this jade putter is ready for action. Putters carved from jade and other materials are crafty additions to the golf club arsenal and could lead to some artful moves on the green. In the late 1800s, the American military modified road bicycles to help infantrymen cross rough terrain. But it wasn't until the late 1970s that mountain bikes hit the consumer market. The popularity of mountain biking has grown ever since. Mountain bikes are specially designed to perform on rough terrain. They have a suspension to help keep the wheels in contact with the ground, deep-treaded tires for added traction, and powerful disc brakes for safety. The frame is made from tubes of aluminum alloy. Aluminum is lighter than steel and cheaper than carbon fiber. They cut each tube to the required length. They use jigs to get consistent dimensions and precise cutting angles. This will be extremely important when they assemble the frame. Each model and size of frame has its own welding jig. After welding, the aluminum frame undergoes a heat treatment. First, the frames are heated intensely, then quickly quenched in a cool bath. This makes the metal easier to work with. This next step is necessary because slight deformations are created in the frame during welding. Using precise measuring instruments and a rubber mallet to avoid denting the metal, a technician ensures that the frame is perfectly parallel to the alignment table. It's not easy to align the shorter tubes, so he uses a longer rod for this task. After alignment, the frame will be heated one last time to harden the aluminum. Once the aluminum exhibits the right mechanical properties, it's ready for boring. This crucial procedure makes the inside of the hole perfectly straight and aligned with the frame's geometric design. Next, they spray auto-grade paint on the bike's frame, which then dries in an oven for 20 minutes. They use ink transfer tape to apply the logo on the bicycle frame. After that logo dries in an oven, they finish the job with a clear coat of varnish. Everything must be perfect. When buying a new bicycle, most mountain bikers pay very close attention to the quality of the paint job. The bicycle is ready for the final assembly. The assembler starts with the rear shock absorber. It contains oil to dampen the suspension movement, so the suspension doesn't bounce up and down uncontrollably after an impact. The stiffness of that dampening is adjustable by the rider. The assembler links the shock absorber to the seat stay. He installs the handlebar and the stem on the steering column. Next, he installs the rear brake caliper. This is a hydraulic brake actioned by brake fluid that travels through a hydraulic hose. It's positioned on the frame in such a way that anchoring clips don't restrict its movement. Now it's time to install the crankset and the derailleurs. These are useful on technical terrain, where quick gear changes are useful to successfully maneuvering trail obstacles. He installs the rear wheel. It's equipped with 10 cogs and a disc brake. Its deep-treaded tire will grip the ground of treacherous mountain paths. Now he screws in the front brake caliper. It takes about an hour to fully assemble the mountain bike. The fork provides the front suspension, while the rear suspension is connected to the rear wheel through a system of pivots at the back. As the wheel and pivots move back and forth, their movement is dampened by the shock absorber, helping to keep the wheel in contact with the ground. Mountain bikes are engineered to withstand the demands of off-road racing. Precise manufacturing and testing ensure that this mountain bike will survive years of use and abuse.